She got math to prove it.
There literally is that's how they prove it. I don't understand math at that level to tell you guys about it, but it is math. All right, okay. Do these two without a calculator.
5/8.
All right, this is going back to 5th grade.
5/8.
What have you got to have before you can add? Common denominator.
Wait, you get a common factor for the bottom?
So on the first one, what's the easiest thing to use for your common denominator? 8.
5/8.
Is it 4 8s?
5/8.
I did get 5.
What?
Whenever you change that to an 8, check over here. Let's see where we're at. Okay. All right, let's look at it. Okay. So, everybody listen to me. I recognize that you have calculators that will do this for you. But we are about to have to do it with variables and stuff. And the calculator will not do it with variables. So if you don't understand how to do this with numbers by hand, you have no chance of being able to do it with those letters in it, right? So, if we look at the first one, you have to have common denominators, because what you're looking at, if you're thinking about what's happening here, I like to think of pizzas. So you have 1/4 of a pizza. Oh, let's unfreeze. Okay. And then you have 3/8 of a pizza that you're adding here together. You can't add those together and say it's 4 pieces. It is, I guess it's 4 pieces of pizza, but are they equal pieces of pizza? They are not, right? So if I want to know how much of a pizza I have with that, then I can't just add them together because all the pieces have to be the same size before I can add them together. So that bottom number is how many slices you have in your pizza, right? And those have to be the same before you can add them together. So the way that you do that is you're going to look for a common factor. And so we could just multiply 4 by 2 and it would give us 8, right? But you can't just multiply the bottom of a fraction by something. You must also multiply the top. The reason this works is because what you're doing is you're doing 1/4 times 2 over 2. And what is 2 divided by 2? 1. And if you multiply something by 1, does it change its value? It does not. So we can multiply this and it doesn't change the value. So we have 2/8 plus 3/8, which is going to give us 5/8. Not 5 over 16. Alright, you do not add the bottom, because the bottom just tells you the number of slices in the pizza. Right? That does not tell you how many slices, it's number of slices. It doesn't change. Alright. Okay? Alright, number 2. What should we use? 15. Alright? So that means you're going to have to multiply both of these. To get 15, you'd have to multiply the bottom of this by 3. Which means you also need to multiply the top by 3. You're going to get 12 over 15. For the second fraction, to get 15 in the bottom, you've got to multiply by 5. You must also multiply the top by 5. You will get 10 over 15. You are subtracting here, so you subtract the top. 12 minus 10 is 2. The bottom stays the same. It's 15.
I was trying to get you wrong.
All right. So, now, this is one of the things I think sometimes they teach a little bit too early because you learn this in 5th and 6th grade. It is not a terribly difficult concept, but it probably felt difficult to you whenever you were doing it in 5th or 6th grade because you might not have been ready for it. You might not have had the background that you needed to be able to do it. So, a lot of times I find that kids had no clue what to do with fractions, but if they relearn it now, it's not all that bad. You just have to know the rules of how to deal with it. Because you are older, hopefully more mature, although Carlos and Katie might be proven otherwise right now. Your brains have developed more and maybe can handle things that used to blow your mind whenever you were in 5th and 6th grade. So I know fractions for a lot of students make you feel like, oh, I just don't even want to think about doing this. Like, I hate them. I don't want to do it. But the rules are, I'm not going to say it's easy, but you might be better at it now than you were back then. So give it a try. Okay? So today we will be adding and subtracting rational expressions. So we got to do this, but we got to put x's in it. So here are our first 2 examples that we're going to look at. Okay? This first problem, before we can add things together, what do we have to have? Like denominators. Do we have like denominators on the first problem? We do. So that is very good because that means we don't have to do anything special with this. Now, you do have to be careful because if we want to put these together, we are taking the top of this fraction, u minus 6v, and we are subtracting the top of the second fraction. You need to put some parentheses around that because you're subtracting that whole thing. And then we can put this all over 24v squared because they have that same denominator, so we just keep that denominator. We're okay here. With the subtraction, it's really important that you have parentheses around that second part because what we need to do, that's like having a -1 right there. We have to distribute that -1. So we would have u minus 6v minus u plus v over 24v squared. And then you would want to combine your like terms. So it might help to put some 1s right here. If that helps you picture what's going on. If I have 1u minus 1u, what's that? Cancels out. It's 0. It goes away. All right. If I have negative 6v and positive 1v, negative 5v. So I've got negative 5v over 24v squared. Now, I do want to see if this will simplify. Does 5 over 24 reduce? No, it does not. What about the v's, though? I've got a v on top and 2 v's on bottom. I can get rid of one of them, right? So I can cancel this with one of these down here. So I could write it as negative 5 over 24v. And that would be as simplified as I could get for this.
Wait, so why we change this?
What that means right there, Passion, is you got like negative 5v over 24v squared means that you got v times v. Like you got two v's there. So this v can cancel with one of these v's down here. So that's why the square went away and we don't have a v in the top anymore. Good question. Carlos. Particularly active today.
Wait, 16 years?
Yeah. This is my 16th year teaching. Mhm.
And then,
What's your mom's name?
Krista Reed. Krista Nicole Reed. She goes by Nicole. I know Coach Wood taught her.
I don't think so. When I first came here, I had a lot of underclassmen, so she probably would, if she was here while I was here, she probably would have been an upperclassman. So, huh? That's your mom? Who's your mom? I remember a Geo. I don't remember a last name though. I don't think I had him, but I do remember him being at the school. 15. I only taught 1 year somewhere else. Yeah, I taught both of them. I remember them. Huh? I don't think I taught her. I don't think. Okay. Example 2. Let's not dwell any longer on how old Messiah is, and just focus on the fact that we need to be able to do this. So, because we're gonna have a quiz tomorrow. Okay. So, example 2. We do not have common denominators here. So, let's start with the numbers first. I got a 3 and a 6. What number should I use? 6. So, I already have a 6 here. What do I need to multiply the second fraction by? 2. Now, when I do this, I'm going to multiply by 2 in the bottom. I'm going to multiply by 2 in the top, but make sure you put parentheses around what you've got in that numerator, because you have to multiply the whole thing by 2. Okay, so that'll give me 6y squared. Now, over here, I've only got 1y. Okay, so to get that to be y squared, I'm going to multiply by y on top and bottom. You might feel like you should square top and bottom. That is not something we can do, because think about if I do that. If I have 1/2 and I square the top and square the bottom, I would get 1/4. Is that equal to 1/2? No. So you cannot square the top and bottom of a fraction. So if you need more y's or more x's, you have to multiply by that number of y's or x's. Okay, so this gives me 2 times x minus 4y plus 5. I'm just going to write that xy like that. And then the denominators for both of these are 6y squared. Because if I do 2 times 3y squared, I'll get 6y squared. If I do 6y times y, I'll get 6y squared. So they're the same. There. And if I have the same denominator, I can just write it all over the same denominator. And so what I need to do now is just simplify the top if I can. There's not a lot you can do here. You could distribute that 2. So you would get 2x minus 8y plus 5xy over 6y squared. Do I have anything that I can combine there? I don't, because they're all different terms. This has an x, this has a y, this has an x and a y. They can't be combined. Can I, cancel out this y squared with anything? I cannot. Because Over here, I could because I only had like one term on the top, right? 5 was multiplied by v. These are all separated out by plus or minus signs, so you cannot cancel anything there. You would just leave your answer like this. For that. If I needed like 3 y's, I could multiply this by like y squared on top and bottom. There might be. There might be. We got some more examples coming up. They'll help us with that. All right. Okay. All right. Let's look at 3. All right. So I've got r plus 6 over r minus 4 plus 3/4. I need a common denominator here. And it feels like I should be able to maybe do like r minus, oh wait, hold on. Don't have my pen. Okay, like r minus right here and r minus right here. Let's think about if we can do that. Like if I have 1/2 and I do 1 minus right here and 1 minus right here, I get 0 over 1. Does that still equal 1/2? It does not. So you cannot add or subtract something to the top and bottom of a fraction. The only thing you can do to a fraction for it to remain the same value is to either multiply the top and bottom by the same number or divide the top and bottom by the same number, which is what we usually do when we're reducing. For this, we're mostly going to multiply. So I'm going to use your least common denominator for this, which a lot of times I'll call LCD, right? Least common denominator. So the least common denominator is just going to have to be the 2 denominators multiplied together. Kind of like we did on that second example that we did on these notes. We had a 5 and a 3, right? And there was nothing I could multiply 5 by to get 3, nothing I could multiply 3 by to get 5. So I just had to do 5 times 3, right, as my denominator, which was 15. So my least common denominator here is going to be 4 times r minus 4. Which means I need the denominator of both of these fractions to be 4 times r minus 4. Okay, so notice I put parentheses around the numerator right here. I'm going to do that because if I multiply the top and bottom of this fraction by something, I need to multiply the whole top, not just the r or just the 6. I have to multiply the whole thing. So I put some parentheses. Over here I've got r minus 4. I want to have 4 times r minus 4. What am I missing? The 4. So I just need to multiply the top by 4 and the bottom by 4 right here. And that gives me 4 r minus 4. Okay. Over here, I want to get 4 times r minus 4. What am I missing? R minus 4. So I'm going to multiply the bottom by r minus 4 and the top by r minus 4. Okay, so now that these denominators match, I can put the stuff together because they have the same denominator. So I will have 4 times r plus 6 plus 3 times r minus 4 all over 4 times r minus 4. Okay, here. At this point, I would leave the bottom like it is. I would just keep it 4 times r minus 4. You can multiply it back if you want, but you don't have to. The top, we do want to try to like simplify and combine like terms if we can. So we would distribute that 4. So we got 4r plus 24 And the 3 we have to distribute as well. So we got plus 3r minus 12 all over 4 times r minus 4. And then I want to combine any like terms if I can. Alvin, what could I put together on this? I cannot put those together. The 4r and the 3r can be put together. So that will give me 7r. And then Jason, what else can I put together in that numerator? 24 and that negative 12. That'll give me a positive 12. And I got 4 times r minus 4. And there's not really anything else I can do with that. There's nothing that will cancel. It won't reduce. I can't like divide all those numbers by something. So this would just be my answer. Yes? You can. The only reason I wouldn't is because every once in a while it will cancel with something in the top. And so then if it's already factored, you don't have to factor and it will just cancel out. So I would leave it like this. It is possible that on a multiple choice question, they might do that. And the answer would be 4r minus 16. That would also be okay if you did that. But every once in a while, that denominator will cancel with the numerator, so I like to just keep it factored. It's a good question. Okay, so, and I really should be doing this. These have excluded values also. What can r not equal for this? R cannot equal 4 because a 4 right there would give you a 0 in the denominator.
Wait, so we put the opposite of what it would give us if it was like to get 0.
Yeah.
So I don't have to put the square opposite.
You just put the opposite of whatever's there. So, yeah. So it's not both. It's just that one. Yeah. Sometimes it ends up like there's a plus 4 and a minus 4, so you get both, but it's only if you have both of those factors there. So for this one, it would just be positive 4.
Okay, so unless it's in the bottom, you don't put it.
Right. Only what's in the bottom. Yeah. And this 4 right here doesn't have a variable with it, so we just don't do anything with it. It's this 4 right here that's making it restricted. Yeah. Yeah, it's gotta have that variable with it. Alright. Okay. Number 4. This will be a little bit easier because if we simplify before we start putting this stuff together. So, Drew, whenever I look at this, what could I reduce before I even start doing this problem? The 3's, right, could cancel each other out. It'll make the problem easier to add together if I cancel that out first. And you can do that because the 3's multiplied. This is all in the same fraction. Now, I could not cancel a 3 with a 3 way over here because you got that big minus sign in between. But these 2 right here you can cancel. So I would have 1 over n plus 2 minus 2n over n minus 4. So I have to decide what my least common denominator needs to be for this. It's more complicated than that. Okay? It is going to be n plus 2 times n minus 4. Okay, because you got those like plus and minus signs, it just has to be the 2 factors there. So, you want the denominators of both of these fractions to be n plus 2 times n minus 4. You want both of those to be there. So, for the first fraction, okay, for this first fraction, I want that denominator to be n plus 2 times n minus 4. So, what's missing? The n minus 4, right? I don't have an n minus 4. So, I've got to multiply this by n minus 4. if I multiply the bottom by n minus 4, I also have to multiply the top by n minus 4. I need to do the same thing for the second fraction. I've got an n minus 4 there. What am I missing? The n plus 2. So I've got n plus 2 that I have to multiply by here. And I also have to multiply by n by 2 in the top. N plus 2 in the top. So now, these denominators match. They're not in the same order, but that doesn't matter. They match because we could switch the order and it's fine. So I would have 1 times n minus 4, that's one's kind of unnecessary, but I'm going to write it anyway, minus 2n times n plus 2 all over n plus 2 times n minus 4. And much like the last problem, Wade, I could multiply those two together, but I'm not going to. I'm just going to leave it factored. It makes your life easier, and if anything cancels, you'll be able to see it more easily. They don't usually cancel, but sometimes they do. Now, I do need to simplify that numerator because I've got some stuff that I can combine. So I would distribute this 1. The 1's kind of unnecessary. You don't really have to have it. You just get n minus 4 there. And here you're distributing that negative 2n. So you get, what is 2n times n? Negative 2n squared. And then negative 2n times 2 will give us negative 4n. All over n plus 2 times n minus 4. And so I could put this 1n together with that negative 4n. And I usually like to write these in order. So I'm going to write negative 2n squared minus 3n minus 4 over n plus 2 times n minus 4. This n right here has a 1, and we're combining it with that negative 4. So the 1 minus 4 will give you a negative 3 right there. Sometimes they'll like factor out a negative, try to factor further. I don't think it'll factor further on that, but we're just going to leave it here. Yes, x cannot equal negative 2. X cannot equal positive 4. I should be using an n right there instead of x. Okay. Questions? All right. Let's continue on. Yes. Go ahead. You don't have to, but it makes it a little bit easier to do the problem if you do. So like over here we could not do that because you can't reduce this because you got the plus or minus signs right there, and 3/4 is already reduced. So we can't do that. But because there's a 3 on top and bottom here, and this is multiplied by that, you can reduce it first by dividing top and bottom by 3. It just makes it a little bit easier to do the problem because you don't have that 3 there as well.
Why do we find those distributions? Like, does that actually help us, or is it just something like that?
It is a technicality that sometimes they throw in, like these two things. For this, it's almost like your domain. You can't have a negative 2. You can't plug a negative 2 or a 4 into it. When we get to solving equations, which is the last thing we'll do in this unit, you have to know that because you might solve it and you might get the answer is negative 2, but the answer can't be negative 2 because it gives you 0 at the bottom. So we're just kind of doing it right now. Right. So, like if you go graph this and you like take your cursor to to that point, you'll have a hole in the graph that'll make like an open circle there. So that's what this is for. If you leave that off, I'm not the most upset with you right now. This is the main thing, getting this. It would be good if you also know the restricted values. On the quiz you're going to have tomorrow, I think I've got one where I just asked for restricted values. So I give you a problem. I think it's like the ones we did yesterday, and you just have to tell what the restricted values are. Pretty much for the rest of them, you don't have to worry about the restricted values. Yeah, you don't have to solve it. You just have to tell what the restricted values will be. Okay. All right, so let's continue on. All right, and let's see. I need to, how many more we got? Is this the last one? Okay, last two. All right. Okay, so for the example 5, it looks like my least common denominator needs to be 2v times 2v squared minus 8v, which is complicated and I don't like it. So instead, what I can do before I try to do a least common denominator is I could try to factor. I haven't really had anything that would factor so far. But 2v squared minus 8v does have a greatest common factor, right? What is the greatest common factor? 2v. So this, I could leave this one alone, 3 over 2v, and I could factor out a 2v right here, and so that's like dividing by 2v here and dividing by 2v here, and I would get v minus 4. This is going to make it easier because if I want the denominators to match my least common denominator, what could I use now? 2v times v minus 4, which is going to be a lot easier to do than having to use like 2v times 2v squared minus 8v, right? That's a lot more complicated. This is a common denominator. It's not the least common denominator. You could do it that way, but you'd have to simplify a lot at the end. So if you factor the denominator, then if I'm looking for this to be 2v times v minus 4, I've got that over here on the second fraction. What am I missing on the first fraction? V minus 4, right? I need a v minus 4 here. And if I multiply by v minus 4 in the bottom, I also have to multiply by v minus 4 in the top. Okay there? So then, now that my denominators match, they're the same, I can just write it all together. So I'll have 3 times v minus 4 plus 4v all over 2v times v minus 4. And we want to try to simplify that numerator to see what happens. If I distribute here, I will get 3v minus 12 plus 4v over, just leave this as it is. And then I could put the 3v and the 4v together, and I would get 7v minus 12 over 2v times v minus 4. And nothing's going to simplify there. You just leave it like that. Okay, questions? All right, 6 is the hardest one that we're going to come across. Something like this is the most difficult that you'll see. So for this, there's nothing I can do to that. Oh, there is something I could do to that first. I don't know if it's going to help. I could cancel the x's, right, and make it 2/3. It actually might help. It might help. We'll look at it here in a second. But over here I need to factor this denominator, right? Do I have a greatest common factor? 2x, right? I could divide by 2x. If I do, I would get x squared plus 3x plus 4. 2. Yes, thank you. I did not. I was thinking it was not going to work out because that won't factor any further. This will, though. Thank you. All right, so what I've got here is I've got 2x over 3x minus 5x over. Can I factor x squared plus 3x plus 2? I may not even want to, actually, but I could, but I don't think it's going to help me. Let's not. Okay. Now, I do have some things that can cancel here. This x can cancel with this x. And this x can cancel with this x. How about this 2 with this 2? No, because of that minus sign right there. They're not in the same fraction. If it was multiplication, I could cancel those, but this is a minus sign, so I can't do that. So we need to think about what we want our least common denominator to be for this. I've got 2 numbers right here. I got 3 and 2. What number would be the least common denominator for 3 and 2? 6. You're going to have to use 6 for that because there's nothing you can, not a whole number you can multiply 3 by to get 2. So you're going to do 6 for your coefficient out there. And then both of these are going to need x squared plus 3x plus 2. Because you got that in the denominator over here, so you need it over here as well. I'm going to start with the second one first because it's the closest. I've got 2 times x squared plus 3x plus 2. What do I need to multiply that by so that I'd get 6? Just a 3, right? Multiply by 3 on top and bottom. How about the first fraction? I got a 3 is all I've got right there. Got to multiply it by 2 on top and bottom so I can get that 6. What else do I have to multiply it by? X squared plus 3x plus 2 on top and bottom. So 2 times 3 is 6. 6 x squared plus 3x plus 2. Over here, 3 times 2 is 6. 6 times 3x squared plus 3x plus 2. So these right here match now. So I can write this together. I'm going to go ahead and do 2 times 2 is 4 times x squared plus 3x plus 2 minus 3 times 5 is 15. And then my denominator is the same. I got 6 times x squared plus 3x plus 2. Why is it only minus 15? Because I already had an x squared plus 3x plus 2 in the bottom of that fraction, right? So I did not have to multiply the top of that fraction by 8. The minus comes from the minus sign in between, and the 3 times 5 is your 15. It's really easy to miss that 8 and 2. It's like one of the biggest mistakes students usually make is that they ignore that that negative is there. All right, so we can simplify a little bit in that numerator. We could distribute that. We could distribute that 4. I'll write that. Ignore that. So we got 4x squared plus 12x plus 8 minus 15. You can distribute in the bottom or leave it. I'm just going to leave it. And so this is going to give us 4x squared plus 12x minus, 8 minus 15 is going to give us 7 over 6 times x squared plus 3x plus 2. And like I said, they may distribute that 6 in the bottom or they may leave it like it is for that. But we could stop here. I don't think we'll factor further. No, won't. Do you have to have common denominators to multiply? Not to multiply. The stuff we were doing yesterday did not have to have common denominators. What I find a lot of times is we do this, and then kids go back to the stuff from yesterday, and they want to do common denominators. It's only for adding and subtracting. Okay, only for adding and subtracting. Okay, so okay, I'm gonna give you guys a little bit different instructions because I know we don't have a lot of time to practice this. So we are gonna have a quiz tomorrow, and we will review some in class before we take our quiz. Do we have pep rally? I think we have pep rally. I think class is going to be.
We don't have a game tomorrow.
Next week, you-
We have a game today. And then we have a game tomorrow.
Yep, yep.
Why do I have it? Let me check and see if there's any reason I was thinking it's pep rally tomorrow. Maybe it's next week. All right, let me check real quick.